Right, so A-level pure maths, integration by first principle. Save this for later if you need it for later, or if you're a parent, do share this with your child. So the whole idea of integration is finding areas under curves. So we're going to try and approximate an area under a curve between x equals a and x equals b. So we can use rectangles to do this, okay? We can draw some rectangles in with a base of dx. That's what we call it. We say the base is dx, a small base dx. And the idea is that we want to use more and more rectangles because more rectangles means a better approximation. So the area, of course, of a rectangle is base times height. So we've got all these bases times all the heights, right? So that's what I've written here, right? So dx is the base, and then all of these f values are the heights, right? So we can write this using sigma notation, as you'll just see in a second. We can say that this is the sum from x equals a to b of f of x times by delta x, as you see right here. So now to get a more approximate answer, of course, you want the delta x to be as close to 0 as possible, right? We want that delta x to tend to 0, so to be as virtually close to 0 as possible without making it 0. So the way that we write this in maths is we say that this is a limit. We take a limit as delta x goes to 0 of this summation here. Now, to save a bit of time, in maths, we don't write limit and a sigma sign next to each other. We write this integration curly sign that you've probably seen before. So that's where it all comes from. Now, just you may notice something. Notice how the delta x goes to dx instead. So we use dx for a really, really infinitely small base of delta x, and delta x is just the base we use in the proof. So hopefully that makes sense.